everybody, how are you all? I hope you all are doing great. So in this video I'm going to start lecture number 5 series. Previous lecture we have discussed the Princeton's theorems, which we have also discussed the counter example, as well as we have discussed an example. So if you didn't see it, go and check it out. And now we are starting towards lecture number 5. So here the positive term series we are doing with the various comparisons test. So here is the direct comparison test, which says that let two series like an and bn are the series, positive term series, because we are doing everything in a positive term series. These are all the tests for positive term series. Okay, so a series of positive terms, there exists k which belongs to a natural number such that an which is less than bn. This is an means the sequence an, and bn means like ये सीरीज वाला ऑप्शन हटा के जस्ट ये दिस पार्ट an मीन्स अगर मैं कोई सीरीज लिखती हूँ 1/n, so this is just the an part. So this an is less than equals to bn for all n greater than equals to k. Then first part is if this series bn is convergent, then series an is convergent, and if the series an is divergent, then this series bn is divergent. मतलब कहने का मतलब ये है, अगर bn divergent convergent होगा, then only an can be divergent, and if an is divergent, then only bn is divergent. This is known as the direct comparison test. So now check the convergence of the series, where the series is e to the power minus of n square. यहाँ पर हमें ये पता है that this is we have a basic standard expansion of e to the power x का. So वो लिखेंगे that e to the power x is 1 plus x divided by 1 factorial plus x square divided by 2 factorial plus and so on, x to the power n divided by n factorial and so on. This is the expansion for e to the power x. Now we know that exponential e to the power x is always greater than x any polynomial y is equals to x. हम ग्राफ से भी देख सकते हैं, like e to the power x का either this graph we have, or y is equals to x का we have this graph. So we know that e to the power x is always greater than x for all x which is greater than 0. So e x की जगह पर हमें यहाँ क्या चाहिए, माइनस ऑफ एन स्क्वायर. तो अभी हम एन स्क्वायर लेकर के चल रहे हैं. एन स्क्वायर देयरफॉर 1 प्लस एक्स की जगह पर एन आ जाएगा. एन स्क्वायर डिवाइड बाय 1 फैक्टोरियल, एन स्क्वायर का square divided by 2 factorial and so on. We know that this statement is always, this series expansion of e to the power n square is always greater than n square. जैसे हम कर लेते हैं कि 1/n square is always less than 1/n, तो this series is always greater than n square. We know this. So e to the power n square is greater than n square. So 1 divided by e to the power n square is less than 1/n square. साइन चेंज हो जाएगा जब आपका डिनोमिनेटर में जाता है, डिवाइड होता है तो. सो अब हम क्या करेंगे, दैट इज़ e टू द पावर, अगर ये न्यूमिनेटर में जाता है तो ये e टू द पावर माइनस ऑफ n स्क्वायर हो जाता है, विच इज़ लेस देन 1/n स्क्वायर for all n belongs to natural number. So and this series, this summation is convergent series. By direct comparison test we can say that this series is convergent series and this series bn, इसको हम bn लेंगे. ये हमारा an होगा ऑलवेज. जो भी सीरीज़ गिवन होती है दैट इज़ ऑलवेज एन an. हेयर इट इज़ जो हमारे पास लेस देन करके आया, an इज़ लेस देन इक्वल्स टू bn. ये आ गया हमारा डायरेक्ट कंपैरिजन टेस्ट. वी कैन राइट an विच इज़ लेस देन इक्वल्स टू bn, वेयर वी हैव डन दिस एज सेम. तो an विच इज़ लेस देन इक्वल्स टू bn आ गया. सो दिस bn इज़ कन्वर्जेंट. हमने अभी ये डिसाइड करा. अगर ये स्टेटमेंट इसके साथ मैच कर रही है तो मतलब bn इज़ इक्वल्स टू 1/n स्क्वायर. 1/n² है तो हमें पता है कि 1/n² की सीरीज़ कन्वर्जेंट होती है बाय पी सीरीज़ टेस्ट. अगर बी एन कन्वर्जेंट है तो विच इम्प्लाइज दैट if bn is convergent which implies that an is convergent. तो अगर bn convergent है तो e to the power minus n square is a convergent series. So I hope you got it what I'm trying to say, what the comparison test trying to say to you people. So thank you, please like, share and subscribe.